Let's say that you have 50 values of one type that you want to keep together in your program. For example, you might have 50 LEDs and you want to remember which ones are on and off. You could declare 50 separate variables, but that would clutter up your program and make it kind of hard to read. Instead of that, we could use an array. Let's make an array and learn how to use it. Open a new Arduino sketch. At the top of the program, write int my_array, open bracket, 10, close bracket, semicolon. This creates a new global array named myArray with 10 elements. All the elements in an array must be the same type. In this case, each element is an integer. It's just like declaring a single variable, but you add brackets at the end of the variable name with a number in between the brackets to show how many elements you want in the array. We've declared the array, so now we need to put values in each element. This is where for loops come in handy. In setup, write serial.begin 9600, followed by for, open parentheses, int I equals 0, semicolon, I less than 10, semicolon, I plus plus, close parentheses, open curly brace. Then my_array, open bracket, I, close bracket, equals I times 5, semicolon, close curly braces. First of all, notice that we declared I as a new variable inside the for loop parentheses. I's scope is contained within the for loop, but its value persists between iterations. However, once the for loop is done running, I will no longer exist. Now, we access an array by placing brackets after the variable name with the index of the element we want to access. Note that arrays in C are zero-based. This means the first element has an index of 0, the second element has the index of 1, and so on. What we're doing here is counting by fives, starting with 0, and storing them into the array. Let's see what this looks like as a picture. When we first start our program, we create an array of integers with 10 elements. These elements can be accessed by using the numbers 0 through 9. Even though we declared the array, we have not written any numbers to its elements, and each element is a full integer. While there might be numbers in there, we have to assume they are random. So it's a bad idea to read from an array without first initializing the elements to some values. In our setup function, we create a for loop that iterates through each element, assigning a value to that element. In the first iteration, I is 0, and we access the element with the index of 0, which is the first element. In it, we store the value 0 times 5, which is 0. In the next iteration of the for loop, I is 1, so we access the element with the index of 1, which is the second element. In it, we store the value of 1 times 5, which is 5. We then repeat this process for the next element, which is index 2. We store 2 times 5, which is 10. We continue doing this for the rest of the elements. That's how we access arrays to assign values to the elements. How do we read values from the elements? Much in the same way. In loop, write serial.println, open parentheses, my_array, open brackets, 3, close brackets, plus 3, close parentheses, semicolon. Then delay 1000. This accesses the element with the index of 3, which is the fourth element, adds 3 and prints the result before waiting 1 second. Run it and look at the serial monitor. You should see 18 printed once every second. Let's go back to our diagram to see what's going on. We first access the element with the index 3. The value in that element is 15. So we retrieve that value and add 3 to it, giving us 18. If we wanted to print all the values in the array, we could replace the serial.println line with the following. For, open parentheses, int I equals 0, semicolon, I less than 10, semicolon, I plus plus, close parentheses, open curly brace. Serial.print my_array, open brackets, I, close brackets. Then serial.print, open quotation marks, space, close quotation marks, close curly brace. Following that, write serial.println, open parentheses, close parentheses, semicolon. This steps through each element in the array, prints its value followed by a space, and then goes to a new line after the array is done printing to the terminal. Upload this program and open the serial monitor. You should see the array appear on each line every second, and it should look very much like the array in our diagrams. What happens if we tried to access elements before and after our array? Change the initialization and condition in the for loop to int I equals -1, semicolon, I less than 11. This will try to print the element before the 0 index and the element at index 10. As it turns out, this attempts to read elements from an array with 12 elements, and we only made an array with 10 elements. Do you think this will compile, or will it give us some errors? As it turns out, C lets us get away with a lot, even if it's wrong. This program will compile and run. Try it. You should see something random printed for the -1 element and something random printed for the 10th element. That's because in C, arrays are stored in memory along with other variables and potentially other pieces of the program. When we index something out of bounds for the array we created, we get whatever's in that piece of memory. This could be anything, as we generally don't know how the compiler organizes the memory. This is extremely dangerous and is known as having an index out of bounds of the array. Trying to read an element that's out of bounds can give you random results. Trying to write an element that's out of bounds can be even more dangerous. You may overwrite another variable, or worse, crash the program by overwriting a piece of program memory. To avoid this, always carefully check how you are indexing your array. It can help to define a constant before your array with the array's length and use that instead of writing the number of elements every time. To do this, we need to use the keyword const before int, which tells the compiler that this variable will never change throughout the program. Write const int len equals 10 semicolon above the myArray declaration. Then, every time you are setting the array length or stepping through the array, replace 10 with len. Upload and run. You should see the expected result of stepping through and printing our 10-element array. If you ever need to change the length of the array in the program, you only need to change one number instead of 3. There is another way to initialize an array. Delete the first for loop. Then, where we declare myArray, add equals, open curly brace, 0, 5, 10, 15, 20, close curly brace, semicolon. This creates an array with 10 elements and assigns the values to the first 5 elements. Note that we can assign anywhere between no values and up to the length of the array. If we tried to assign 11 initial values to a 10-element array, we would get a compiler error. However, we only want the first 5 elements assigned. Run this and you should see those 5 values printed followed by 5 zeros. It's nice that the elements we didn't assign are filled with zeros, but don't count on this happening. You should assume that elements you don't assign values to can be any random number. You can also initialize an array like this without having to specify the number of elements. The compiler looks at the number of elements between the curly braces and creates an array of that size. In this case, we are creating an array with 5 elements. What do you think will happen when we run this? Can you spot the error? We did not update our length variable. If we run this, we try to print the elements past the end of the array. We get the values we assigned plus 5 random numbers. We need to change 10 to 5 to make this work. Run it again and we see the 5 elements we assigned. Now, let's talk about a special kind of array, the string. A string is an array of characters which can include numbers, letters, spaces, and any special characters from the ASCII table. Change the myArray definition line to char myArray open brackets len close brackets equals hello in quotation marks, followed by a semicolon. Each character is an element. Even though hello is 5 characters, we actually need an array of at least 6 elements to store the string. Why? When we create a string using double quotes like our hello, The compiler automatically creates an element out of each character and then appends a null character to the end. This null character, which is the value 0 in the ASCII table, is defined using 2 characters, even though it's actually 1. The backslash is known as an escape character, and when used in conjunction with some other characters, represents special characters not found on most keyboards. In this case, backslash 0 refers to the null character and is automatically added by the compiler to terminate strings. The last 4 elements are filled with unknown values. They could be 0, but who really knows? Let's remove the serial.println space line so that the characters in our string are printed next to each other. Run this and you should see hello printed in your terminal once every second. It seems to be working, but the program could be trying to print values in the string that don't exist. They're likely 0, but we don't know, and you could potentially end up with weird characters being printed. To prevent this, let's add a check to stop printing when we see the null character. In the for loop, before we print, add if, open parentheses, myArray, open brackets, I, close brackets, equals equals, single quote, backslash 0, single quote, close parentheses, open curly brace. Then break, semicolon, and then make sure Arduino has put in a closed curly brace. This checks each character, and if it's the null character, break out of the for loop before it's printed. Run this, and you should see the same hello being printed. This is great and should give you an idea of how strings work, but there is a much easier way to print strings to the terminal. Replace the whole for loop and serial.println line with serial.println, open parentheses, my_array, close parentheses, semicolon. Yep, the print and println functions know how to deal with strings. They will print all the characters in the character array up until it sees a null character and then stops, much like we did in our for loop. Just remember to have at least one more element in your array than the number of characters you think you'll need. You can also let the compiler create the necessary length of array by putting nothing between the brackets in your array declaration. For our program, myArray will be 6 elements long. Note that this is only really helpful when you have a string that doesn't change. Trying to assign another string with more than 5 characters to myArray later in the program might result in bad things. Arrays are super helpful when it comes to storing many values of the same type, and strings are really just a special type of array. You'll find yourself using arrays quite often when it comes to doing things like trying to control a bunch of LEDs at the same time, or reading and writing values to and from the serial monitor.